I wanted to take a few minutes to go over some things for the Chapter 9 test. And these are important. Some of these are things that we covered in the exercises that we did. And some are things that are in the content or in the textbook that you need to be aware of because they will be on the test. So first of all, remember, we say that interfaces are abstract, meaning they do not have implementation code. There's no code per se in the interface file. It's a skeleton. It's an outline. It's a contract between itself and the classes that implement it, specifying the names and the return types of the methods that each class will have that the interface requires. But the code, the implementation, the concrete stuff that makes up the methods, that is not in the interface. That is in each class file that implements it. So we say interfaces are abstract. And remember, when you're creating an interface, you use the words public interface, not public class, to create it. So public interface, interface name, and notice all I have here is an outline. I have the method names that the interface is going to require in each class that implements it. I have their return type and name. And notice I do not put the word public double get amount. I do not put public string get name because by default all of the methods in an interface must be public. That's the whole crux of the thing. If these are not public methods, then you couldn't have each class implementing them. It would not work. So the methods in an interface are by default public, therefore you do not have to put in the interface file the words public in front of each method. They have to be public for other classes to make them accessible and available, so by default they are public. So that's very important that you understand. We say that interfaces are abstract. We use the words public interface to create them. So an interface is like a class, but we say all its members are abstract, and we use the word interface, not class, which I just talked about. Interfaces never have constructors in the interface file itself. So you will never see in a tester like measurable x equals new measurable. Notice there's no constructor here. There's no public measurable paren. Interfaces do not have constructors. Classes have constructors like player and classroom and bids from our example, but the interface itself does not have a constructor, and you will never see this type of a line of code, which is a constructor format for an interface. You will never see that. Interfaces have no instance variables or fields in them, and no method implementations per se. All right. So again, you don't see instance variables here. You don't see code here. And notice we have this weird format: return type, method name, paren, semicolon. Now, if it took parameters, we couldn't have a parameter list within the parentheses. I'm not saying we couldn't have that. What I'm saying is you're not going to see brace, code, brace for any method that's in an interface. You're going to see just this outline of what the method type name is and what it will return. So we declare methods and return types just like this. For example, double get amount, paren, semicolon. Again, if we needed to, we could have a parameter list in here. We do not use the word public or abstract. People will sometimes put abstract double get amount. That's not correct. And the interface does not provide the implementation code, meaning what I mean by that is you're not going to see brace, lines of code brace in an interface method. You're not going to see that. That's going to be in the class that implements the interface. Each class will have its own code or its own implementation of the getAmount method, for example. One thing we did not really do an example of in our program was have multiple interfaces, but each class can implement more than one interface. So if I'm only implementing one interface and I had, player implements measurable, that would mean that player is going to implement the measurable interface. If I had another class, say I had a class song and I had two interfaces, royalties and copyright, and I wanted song to implement both of those, The way I do it is I put the word implements, and then I put whichever one I want to go first, royalties, and then I put a comma, then I put the next interface name. And if I had a third interface, I would put comma interface name here. So a class can implement more than one interface. Doesn't matter what order you put the interface names in, but you just put interface name, comma, interface name, comma, interface name, comma, interface name until you're done. Now, if an interface changes, every class that implements it has to be updated or rewritten. So for example, if I put a new method in here in this interface, I'm now going to have to make sure that every class that implements it, player, classroom, bids, now has an int XYZ method with code in it. And notice how the second I change the interface, every file that implements it now has an error. And it tells me player is not abstract and does not override method XYZ and measurable. What that means is, hey, you don't have an XYZ method in player, but yet you're claiming to implement the measurable interface, and measurable has an XYZ method. So you've got to come into player and put that method into player and classroom and bids, all of the classes that implement it. So I would have to come down here, and notice here I am going to put the word public in front of my XYZ method. And now I'm going to just do something ridiculous here. Oh, it's got to return an int, doesn't it? So I'm just going to have it return some random number. But now I have fixed measurable, because now I have this XYZ method. It returns the integer type, and everything is fine. So if I don't do that, I'm going to not be able to compile those other classes. And the compiler is going to let me know that's a problem. And now, really, all of these should be good. The error goes away. So that's important. If you change the interface, you have to touch every class that implements it and make sure it's in sync with the interface. Now, one thing we did not do, you can convert objects between interface types and class types if that class implements the interface. So if I want to cast or convert, say, an interface object to a player object, say a measurable to a player, I can do that. I can also convert a player to a measurable. So I can convert objects back and forth between classes and interface if that class implements that interface. Okay? So I can convert a measurable object to a player or a classroom or a bid object. I can convert a player object to a measurable. I can convert a classroom object to a measurable. I can convert a bids to a measurable because they implement the measurable class. What I cannot do, for example, is if I have a rectangle object and it does not implement measurable, we know it doesn't because rectangle is part of the Java API that we cannot modify. We cannot force rectangle to implement the measurable interface. We can't modify the rectangle class. So rectangle does not implement measurable. So I cannot convert a rectangle object to a measurable object. I cannot convert a measurable object to a rectangle. I can't convert those guys back and forth because they're not related. Rectangle doesn't implement measurable. But if measurable is an interface, and for example I have a coin class that implements measurable, I can convert back and forth between those two. So if I have an object max that is a measurable object, I created it as a measurable object, and coin implements measurable, I can create a max coin object, and notice I'm just using a cast here. I want max to become a coin, so in parens I put paren coin, paren in front of max, and now I've created a new coin object, max coin, and I'm taking the old measurable max object and converting it. And I can convert the other way as well. Okay, so I can convert measurable objects, like here's my max. Notice I can create a measurable object, but I don't use that whole new measurable paren constructor style. I create my measurable objects by taking player data, okay, which is its own type, it's a group type, and then I get that maximum method and I call that. And if you remember how we used get maximum, I don't have my data class up, but we use this method to basically help us create that measurable object type. So in theory, if I have max and it is a measurable, and I know that player implements max, I can do that. So I can take this measurable type, convert it to a player type. If I have a player, and now, let's see, what does my player take here? Takes a name and a total. I create a player. I can convert back and forth between players and measurable objects. I can do that for classrooms and bids because they all implement the measurable interface. So you can convert one object type to another when they have that relationship. Now, here's the flip side of that. I have a coin and a bank account. They both implement the measurable interface. I cannot convert a coin to a bank account or a bank account to a coin just because they both implement the interface. So I cannot do this sorry, I have to think for a minute. I cannot say, let me take a classroom object. Let me create a classroom object. Let me take XYZ, which is a player, and try to convert it to a classroom, just because they both happen to implement the same interface. I cannot do that. That is not legit. I can convert back and forth between interfaces and class types when those classes implement the interface, but I can't just randomly take two classes that aren't related other than the fact that they both implement an interface and convert between them. Alright, so I've showed you some examples of that. Can you cast a bank account object X and convert it to a measurable object X only if X actually refers to a bank account object? So in other words, again, I can't do this type of thing right here. And finally, make sure you read up in the book on early binding and late binding. When we have overloaded methods in a program, two methods or more that have the same name, but they take slightly different parameter lists, we say they're overloaded. And we have our tester class written, and the tester class is calling one of those overloaded methods. When you compile, the compiler figures out which of the overloaded methods you're calling from the tester before the program actually runs, and we call that early binding. So that's the case where you have overloaded methods and your tester's written. You're compiling the project with a tester, and it's the compiler will figure out before it runs the test, or which version of the overloaded method you're calling. That's called early binding. And also make sure you read up on the section in the textbook where it talks about polymorphism is resolved late. And so that should help you with the test.